Assalamu alaikum wa rahmatullahi wa barakatuh. Student, today's topic is moment of force. The moment of force is equal to the product of magnitude of a force and the perpendicular distance of the force from the pivot point. In the previous video, we discussed the turning effect. Turning effect of a body. How the body will turn. And we had written force into perpendicular distance. This is also known as moment of force. Okay? So here the definition, the moment of force is equal to the product of magnitude of force and perpendicular distance. Magnitude of force and perpendicular distance. So the product of force and distance, perpendicular distance from a pivot point, that is called the moment of force. Here this is one body is there. If a body rotates at this point, this is the pivot point, here this is a body, here this is a body, and this is the pivot point. Okay, and if you apply a force here, then what is the perpendicular distance? Just draw one line. This is the axis of rotation, axis of pivot point. So this is the perpendicular distance. Okay, from here to here, this is the perpendicular distance. Okay, if you apply a force here, then the perpendicular distance will reduce. Now look at the distance, this one distance and this one distance. Okay, so here force applied, here also force applied. Okay, but here if you apply force here, the distance will reduce, here the distance is increased, maximum distance. So this is the force, this is the pivot point P or O, P, and this is the force, and this distance, this is called the distance. So force, product of force and perpendicular distance. So if you apply force here, then the body will rotate in this direction, okay, along this pivot point. So the turning effect or moment of force is equal to force, product of force into perpendicular distance. Turning effect will be greater if the force is more, then turning effect will be more. If the force is less, then the turning effect will also be less. If the perpendicular distance is more, the turning effect or moment of force will be more. Okay, if the perpendicular distance is less, the turning effect will be less. Okay, here look at this. If here 10 Newton force is applied, then the body will rotate with turn. If the force is applied 100 Newton, then the turning effect or moment of force will be more. So by applying more force, turning effect will be more. By reducing the force, the turning effect will be reduced. Or here, if we apply 100 Newton force, but the distance is less distance, smaller distance, and turning effect will be lesser. Okay, and the same 100 Newton force is applied here, the distance is more, the body will rotate more. Okay, so this is the moment of force. Moment of force means product of force and perpendicular distance. Hope you understand. So we will write moment of force about the point O. This is the point O. About the point O equal to force into perpendicular distance from point O. So force, this F, we will write F, and OP is the perpendicular distance. Okay, so moment of force equal to force into perpendicular distance. Now look at this. units of moment of force. What is the units of moment of force? Unit will be here. Look at this turning effect. Turning effect. Right. So the moment of force equal to force into perpendicular distance. Okay, force into perpendicular distance. Now force, SI unit of force is Newton, and perpendicular distance, unit of distance is meter. So the moment of force unit, SI unit is Newton meter. We will write N dot M, Newton meter. Okay, so this is the SI unit of force. Moment of force is also known as torque. Okay, also known as torque. So torque equal to force into displacement, or moment of force equal to force into displacement. Unit of SI unit is Newton meter. CGS, what is the CGS unit? Unit of force in CGS, that is dyne, and this one centimeter. So dyne centimeter. CGS unit of moment of force dyne centimeter, SI unit Newton meter. So what is the relation between SI unit of moment of force and CGS? It means, or in other words, what is the relation between Newton meter and dyne centimeter? Okay, so we know that 1 Newton meter, 1 Newton meter. Now 1 Newton equal to 10 to the power 5 dyne, and meter equal to 1 meter equal to 10 to the power 2 centimeter. 1 Newton equal to 10 to the power 5 dyne. Okay, and 1 meter equal to 100 centimeter, means 10 to the power 2 centimeter. Okay, 1 meter. Now 10 to the power 5, 10 to the power 2, how much? 10 to the power 7 sorry, alhamdulillah, dyne centimeter. So 1 Newton equal to 10 to the power 7 dyne centimeter. Okay, here 1 Newton equal to 10 to the power 7 dyne centimeter. Remember this one, very very important relation. And 1 kgf meter, kilogram force meter, equal to 1 Newton, 10 Newton meter. Nearly, it is near about 9.8. Exact value is 9.8. Okay, 1 kgf equal to 9.8 Newton. Okay, but near about, for calculation we will use 10 Newton. And 1 gram force centimeter equal to 1000 dyne centimeter. Okay, remember these two values. I hope it is clear. Okay, thank you.